Chapter 4.4, the fundamental theorem of calculus. Day 3, the second fundamental theorem of calculus. All right, the fundamental theorem of calculus, if you remember, told us that we could find the area underneath the curve, or the definite integral, by finding the antiderivative of f, which we expressed as capital F, and evaluating it from the upper limit to the lower limit and subtracting upper limit minus lower limit. All right? The second fundamental theorem says we can write this definite integral as just a number, or we can write it as a function. All right? When we write it as a function, though, it's going to be where we have one part constant and one part can vary. Right? We need to make sure we don't use x on both of these because we don't want to use x to mean two different things. So we can write it as a number where we get a specific value, or we can write it as a function where we can have rectangles where the side can go left, right, move around. Right? And then when we do that, there's certain things that happen. One of the things that can happen is, whoa, we can throw the screen around. No. One of the things that can happen is we can just evaluate like a normal function. Evaluate the function. F of x equals the definite integral of cosine from 0 to x. All right? First thing, evaluate at 0, evaluate at pi over 6. Let's start evaluating at 0. F of 0 equals 0 to 0 cosine of t dt. This is easy. What happens when your rectangle, left and right side of your rectangle are right on top of each other? Well, it's a rectangle of 0 width. 0. All right? Let's look at what happens when we put in pi over 6. F of pi over 6. Rectangle from 0 to pi over 6. Cosine of t dt. Start with the antiderivative. Antiderivative of cosine is sine. Zero to pi over 6. Plug those values in. We get sine of pi over 6 minus sine of 0. Sine of pi over 6, 1/2. Sine of 0, 0. So this is 1/2. Good. Well, what else can happen? Well, like any function, we can take the derivative of it. So if we have our function is an integral, our function is an integral, like we got right here, we can take the derivative of it. Well, what's the derivative of the antiderivative? Well, aren't those two things opposites? They'll cancel each other out. The second fundamental theorem of calculus says the derivative of the antiderivative, well, they cancel each other out. You're just left with the function. Right? Keep in mind there's a couple things you need to pay attention to, beware of. The lower limit is a constant. The upper limit is x. Right? We're going to look at what happens when upper limit is more than x. We're going to look at what happens when the lower limit isn't a constant. But for now, the derivative of the antiderivative of a function is the function. So, use the second fundamental theorem of calculus. Find the derivative of the antiderivative of the square root of t squared plus 1 from 0 to x. Well, the derivative, the antiderivative is the function. The only difference is our variable is x. Try that again. Find the derivative. Well, the derivative of the antiderivative, and I shouldn't use that symbol, that something means something later on. The derivative of the antiderivative is the function. All right, now in this case, we got x cubed up there. Let's just substitute something in, all right? Let's let that be u. So u equals x cubed. So I'm just going to replace that, right? Let there be a function inside my function. So the derivative of the antiderivative is the function. So I got cosine of u. However, I replaced it, so there's a function in a function. What do you do when you take in the derivative of a function that has a function in it? Well, that's chain rule. We need to multiply that by the derivative of the function. Derivative of u is u prime. So what we got here, the derivative of the antiderivative is the function, but there's a function inside the function, so we multiply by the derivative of that. And when we put everything back in, we get cosine of x cubed, times 3x squared. So we have our function. We plug in our x squared. But because it's not just x, we then multiply by the derivative of 3x squared, the derivative of x cubed. And really, we did do that back here. It's just the derivative of x is 1. Multiplied by 1. Did it really change anything? No, it didn't. All right? So let's look at this one. Find the derivative. Right? We're going from 1 to x. The derivative of the antiderivative, well, it's the function. All right, find the derivative. We're going from a constant to x. The derivative of the antiderivative, it's the function. All right? Now, it gets a little tricky. What do we do when there's a variable on both top and bottom? All right? I'm going to show you this one longhand. The next one I'm going to show you shortcut. All right? Now, remember there's a property that says antiderivative from a to b of f of x. There's a c where I can split it. I'm going to do that. I'm going to split it. Except I'm going to keep doing that same problem. I'm going to split it. All right? I'm going to do from x to c of 4t plus 1. dt plus from c to x plus 2 of 4t plus 1. All right? Now, the second fundamental theorem has the constant on the bottom. So I'm just going to switch these two here. When I switch these two, remember we have to negate it. That's another property of definite integrals. I can switch the order of the limits, but I'm going to have to change the sign. Now I can apply my fundamental theorem. From a constant to x, the derivative of the antiderivative is the function. So we'll have negative 4x plus 1 plus, from a constant to x plus 2, the derivative of the antiderivative is a function. We'll plug in x plus 2 and then multiply by its derivative, which is 1. All right? Simplify, we got negative 4x minus 1 plus 4x plus 8 plus 1. Negative 4x cancels. Negative 1 and 1 cancels. We're left with 8. All right? So that equals 8. Now, I promised a shortcut. Well, the shortcut, remember the first fundamental theorem? F of b minus f of a. All right, well, derivative of the antiderivative, plug that in, x cubed, minus derivative of the antiderivative, plug that in, negative x cubed, simplify. X cubed plus x cubed, that's 2x cubed. In other words, apply the first fundamental theorem in conjunction with the second fundamental theorem. You're going to subtract with your limits. 2x cubed. So in conclusion, the second fundamental theorem of calculus, the derivative of the antiderivative is the function. Now, little caveat, if we have a u up there, the derivative with respect to x of the function is the function with u inside times u prime. And if there's an expression on top and bottom, let's say u and v, then we'll just have to do f of u, u prime, minus f of v, v prime. Apply the first and fundamental theorem, first and second fundamental theorems in conjunction with the chain rule.